This is Vibhuti Salaria, a student of MSc Physics, Kanya Mahavidyalaya Jalandhar, the Heritage and Autonomous Institution. I am extremely honored to have such a great opportunity to speak before this honorable gathering about the National Science Day. National Science Day is celebrated on February 28 every year across India. National Science Day commemorates the invention of Raman effect by the great physicist Sir Chandrasekhar Venkata Raman. Sir Raman, on this date, has invented Raman effect in the year 1928. For his contribution in the field of science, Sir Raman was awarded with Nobel Prize in Physics in the year 1930. By celebrating this day as National Science Day, we show our dignity and respect to the famous Indian physicist for his contribution in the field of science. So, today our institution is celebrating this day with the theme Integrated Approach in Science and Technology for a Sustainable Future. But due to the prevailing COVID-19 pandemic, this time the Department of Sciences, Kanya Mahavidyalaya Jalandhar, wishes to organize an online interactive session on concepts of physics. Also, it's an indeed pleasure for me to share that today, on the occasion of National Science Day, we have a dynamic personality in between us, Madam Pragya Nopanny ji. It's our fortunate to have you with us, ma'am. Before going ahead, I feel proud to share the history of our reputed heritage and autonomous institution, Kanya Mahavidyalaya Jalandhar, with our resource person specially. Established in 1886, Kanya Mahavidyalaya Jalandhar is the first and only women college in state of Punjab conferred with the autonomous status by UGC Ministry of Education, Government of India. It is a matter of great pride for all the KMVites that, under the leadership of our head of institution, Professor Dr. Atima Sharma Dwivedi, Kanya Mahavidyalaya Jalandhar has been selected among top national institutes in India as per Best Colleges Survey in 1920 and 2019 and 2020 by India Today, and adjourned as #1 autonomous college in Punjab by Outlook magazine. KMV is designated college with potential for excellence and has conferred by Star College status by Department of Biotechnology, Government of India. It is a premier and its own kind of institution with a pride privilege of having been visited by 5 presidents and 5 prime ministers of India. KMV has such a wide history, so let's explore it more with a virtual visit. It's an amazing tour of the Vidyalaya. Now, I would like to invite our worthy and lovable Madam, Dr. Neetu Chopra, to welcome our guest. Over to you, ma'am.
Thanks, dear Vibhuti. Good morning, everyone. On the behalf of PG Department of Physics, I, Dr. Neetu Chopra, feel honored to welcome our today's speaker, Madam Pragya Nopanny ji, on the celebration of National Science Day. It is really a pleasure for me to introduce here Madam Pragya ji, who is experiential learning expert and has been training the trainers on the subject matter. She has been a teacher all her life at Villa Vidya Niketan School. She is founder coordinator of BVN IAPT Anveshika and has been mentored by Dr. H.C. Verma, eminent ex-professor of physics at IIT Kanpur. Ma'am has conducted more than 400 experiential learning workshops in physics and science for the students and teachers across India. She is bestowed with many awards, like in 2016, State Award for Teachers from Directorate of Education, Delhi. In 2017, National Award for Teachers from Government of India, conferred by Vice President of India. In 2018, Lifetime Achievement Award from Indian Association of Physics Teachers. She has been Best Teacher Guide for investigatory projects in Eastern India Science Fair. She has designed many innovative activities and events for experiential learning of physics and multi-dimensional learning across subjects, such as creating memorable classroom experiences, fear to fascination, demo physics, teaching science through stories, and many more to her credit. Ma'am, our institution acknowledges and appreciates you as an eminent women scientist of national and international repute. It would be a huge privilege to have you with us at this special occasion to enlighten our women budding scientists. Dear girls, today ma'am is going to interact with you all on the topic Mindsets for Sustainable Future. It is going to be an interactive session. So students, you can unmute yourself and can share your views whenever asked. Now, without taking much time, I invite Pragya Madam to share her valuable experiences with the audience. Over to you, ma'am.
Thank you so much, Dr. Neetu, and namaskar to all of elderly colleagues, and hello to all the students. You know, when I started my teaching journey, it was in Calcutta in a school called Mahadevi Birla Girls High Secondary School. And all the girls there were from a particular community where most of the girls were after school and after maybe BA, BSc, they were all expecting to get married and look after their families. And I was teaching physics, and I realized that none of them ever thought that they're going to do anything remarkable in their life. And they were just there because they thought that maybe science is good for intellectual development. So in that kind of scenario, my principal told me that, can you do something to make them feel that they're capable of doing something? And for me also, it was a challenge, because when I passed out from Birla Institute of Technology and Science, Pilani, in 1979, and this was the first job in 1989. So for 10 years, I had not been anywhere in education. So this was, to me also, it was a personal challenge that I should also be able to do something remarkable. And, you know, we took up a project where we had to find out the presence of lead in roadside dust. Now, finding lead in anything is extremely difficult, you know, the percentage of lead, because if you start doing any test, even tap water has a lot of lead. And why the lead came in the roadside pollution was because at that time the petrol used to be leaded. So it was such a tough project where one professor from Jadavpur University had designed for us a procedure in which we had to dissolve the dust in roadside dust in different chemicals, and then uh, develop. There were different shades of red that could develop depending upon the percentage of lead in it. And well, 1 month, these girls, they were very hardworking and meticulous in their handwork because they were used to doing a lot of embroidery and fine work. And day and night we did this procedure, and even the police department wanted us to give this data because they did not have this kind of data. And finally, after 1 month, when this project was complete and we entered in Eastern India Science Fair, this was declared the first project ever done on such a topic, and it was declared first in the category. And the whole outlook of the girls changed because they started feeling that they were useful to the society. Because even the police department was asking, the government departments were asking that we've never had this kind of study, we want this study. So it is how you can contribute to society. And if that mindset of contributing to society and science for betterment of society is there, I think there is no turning back from a bright, sustainable future. So what are these mindsets that ensure that we are going to have a good future, a future which is good of health and all the amenities, good water quality, good air quality. You know all about these sustainable goals, sustainable development goals that the world is talking about. But then that goal is there like a bright green goal in front of us. But how do we start inching towards that? What is it that we can do from our own place, from our own individual self? You know, everybody is talking कि ये खराब है, वो खराब है, ये pollution है. तो इसकी एक बहुत बढ़िया लाइन डॉक्टर एच.सी. वर्मा के सोपान आश्रम में जब प्रवेश करते हैं तो वहां लिखी है, अंधकार को क्यों धिक्कारें, अच्छा है एक दीप जलाएं. So rather than criticizing and seeing what is going wrong around us, let us start doing something from our own place. So today I wanted to bring about those mindsets with very simple examples. So with your permission, can I present a PowerPoint? And then through that PowerPoint, I would like to interact with all the people, all the students who are present here. And before I proceed, I also want to say that I am very touched by the welcome that has been accorded to me, and also the visit to your college campus. It really made me feel as though I was right there in that campus. And I can see that in spite of being a very old institution, you have a modern mindset. That is what I gathered from the tour of the campus, modern facilities and modern mindset. And therefore, I am very happy to interact with all of you. So let me share my screen. And here is the presentation through which we will interact. Why I'm not able to share sound and something? It is not able to optimize for video clip. I don't know why. Is there any setting which is not optimized?
Mr. Shashi, can you please tell?
मैम बेसिकली आप क्या देख पा रहे हैं वहाँ पे?
नहीं, वो एक्चुअली नीचे दो बॉक्सेस होते हैं ना, शेयर साउंड एंड ऑप्टिमाइज द वीडियो क्लिप. तो नॉर्मली वो हो जाता है, ऑप्टिमाइज अभी हो नहीं रहा है, बट इन एनी केस लेट मी शेयर एंड सी वेदर इफ इट इज फाइन.
श्योर.
So is the PowerPoint visible?
Yes, ma'am.
Okay. So I'm going to show you a video clip, and I want you to tell me what do you see here, right? So I invite participants to unmute and tell me what do you notice here. I'm going to play this again and again, and the participants could tell me what do they see here. Can they unmute themselves? Dr. Neetu, can the participants unmute themselves?
Yes, ma'am. They can unmute themselves. Girls, be active
म्यूट तो
and
नहीं
give
किया
your
हुआ है
मैम
कर
परमिशन
सकते
दी
हैं
हुई है, परमिशन दी हुई है, कोई भी अनम्यूट कर सकता है.
girls. You can unmute yourself and be interactive.
अब आपने मुझे अपने कॉलेज का तो इतना बढ़िया टूर दिया है और अब आपके साथ बात करके मजा आएगा ना. साइंस अकेले अकेले तो सेलिब्रेट नहीं हो सकता कुछ भी. तो आज तो साइंस डे का सेलिब्रेशन है, तो वी टू सेलिब्रेट इट टुगेदर, तब मजा आएगा.
हाँ जी बेटा बोलो बरजिंदर.
The person has cut the guava into 2 halves.
ठीक है, तो अब आपको ये सिर्फ ये एक सिंगल इवेंट नजर आ रहा है, गुआवा 2 हाफ में कट गया है, या यू कैन सी समथिंग मोर ऑल्सो हियर? आर देयर एनी अदर थिंग्स दैट यू कैन सी हियर?
Ma'am, there is a symmetrical cutting.
Okay, there is symmetrical cutting. What else can you see? What else can you see? Anything that you see, just come out with it.
And the force that is
Ma'am,
applied
the motion.
on the paper.
The force, what? Pardon? Can you kindly repeat?
बोलो बेटे हेजिटेट ना करो.
बेटा ये तो मैंने सिंपल इसीलिए चुना है कि कोई भी इसमें ऐसा टफ फिजिक्स का कॉन्सेप्ट नहीं है जो कि हम नहीं जिस पे डिस्कस कर सकते. सो आई थॉट लेट मी टेक वेरी सिंपल थिंग्स एंड आस्क यू व्हाट you notice. Can you switch on your videos? If there's any hesitation, just let me know if there's any problem. Yes, please.
Yes, girls, keep your videos on. Girls, be interactive. मानसी बताओ क्या लग रहा है आपको इसमें?
देखो बेटा, हम अकेले तो सेलिब्रेशन नहीं कर सकते हैं, है ना. तो सेलिब्रेट तो इकट्ठा ही कर सकते हैं. तो अब आप बताओ कि इसमें आपको क्या नजर आ रहा है. तो बहुत ही सिंपल ऐसा वीडियो है कि जिसमें कुछ भी ऐसी चीज नहीं है जो कि बहुत मुश्किल हो. ये देखो, मैं फिर से चलाती हूँ. हाँ बताइए.
Ma'am, the force which knife is applying on the guava, the sharpness of the knife.
So what about the force? I mean, you can complete your sentence. Can you complete your sentence? Yes.
Ma'am, we are able to see the force applied on the guava with the knife, through which it is cutting the guava into 2 pieces.
Are you able to see the force, or that is your inference? That's your inference, or you are able to really see the force?
Ma'am, that's our inference.
Yes, right. So this is one point that I wanted to make, that there is a difference between observation and inference, right? So which one will always be correct? The observation or the inference?
Yes, Sandeep, you have raised your hand. आप अनम्यूट कर सकते हो संदीप अपने आप को.
हम वहां से स्टार्ट कर रहे हैं जहां से साइंस स्टार्ट होता है, या किसी भी हम फ्यूचर की बात करें तो कोई भी प्रॉब्लम हमारी सॉल्व कब कहाँ से शुरू होती है, कि जहां से हम बहुत कीनली ऑब्जर्व करते हैं, राइट. सो हियर आई एम जस्ट आस्किंग यू टू ऑब्जर्व एंड टेल मी व्हाट डू यू सी.
Ma'am, in this guava fruit is cut by a knife, and also we can say that describe the Newton's first law as like guava is at rest, but when we apply force, it is being cut by a knife. So according to me, I observe like this.
That's okay. But then, did you observe the Newton's first law? I mean, you just said that according to Newton's law, but then did you observe the Newton's first law here?
मैम जैसे पहले गावा बिल्कुल रेस्ट पे था, बट जब
हाँ.
हमने अप्लाई की तो वो मोशन में आई भी, मतलब वो टू स्फेरिकल एक सिमेट्रिकल लाइक जैसे हम सॉलिड एंगल जिसमें होता है तो वो उसमें कट हो गया है.
ठीक है. तो न्यूटन्स लॉ आपको दिख रहा है यहाँ पर, या वो आप इन्फर कर रहे हो, उससे कनेक्ट कर रहे हो?
कनेक्ट कर
रहे हो, राइट. बट आई वांट यू टू टेल मी व्हाट डू यू ऑब्जर्व. So is cutting of guava the only thing that you can observe, or there is more that you can observe?
Ma'am, there is also frictional force on guava as it stops.
Can you see frictional
Inertia of press. Ma'am, Newton's law, inertia of press. Inertia of press.
There is some problem. This video is not playing actually. I think वो video enabled नहीं था, वहाँ पर कुछ issue था. But anyway, let me just keep on sharing it again and again. बेटा, आप जो मुझे बता रहे हो एकदम सही बता रहे हो. But only thing I want to know is that are you able to see the force of friction here? Or that is your inference? That is your inference, or do you see?
Yes, ma'am. Yes, ma'am.
Yes, what? Yes, what?
And we cannot see the frictional force, but we can feel it or observe it.
You cannot observe. That is your inference. What you're observing is that guava is getting cut into pieces. That's all you're observing, right? Now, what more are you observing in this picture?
When the force is applied on a point, and the pressure is being applied due to on a small cross sectional area. Force and pressure concepts here are being related.
Force is being applied on a small cross sectional area. Okay.
And then
what else? What else?
It due to force, it is pressure that is applying on the guava that is helping it to cut.
There is something wrong with this sharing instruction, because it's not playing. It stops playing. The video stops playing.
Ma'am, can I make you host instead of co-hosting?
Will that allow me to play it again?
I am going to permit you hosting permissions now, not co-hosting. I am going to provide you host as host.
All right. All right. So now I can share, right?
Ma'am, you are host now. Now try once again.
Even now that box is not optimized for video viewing. Anyway, let me try again. So what I want to point out is, see, this is how we confine ourselves into some invisible chains. You see, in this video, I can see the shadow. I can see the image. I can see the color of the, even now it's not playing. There is something wrong with this permission.
एक बार शशि सर, अगर दोबारा से हम ज्वाइन करवाएं मैम को, मे बी वो वर्क करे. कई बार सेटिंग्स में हो जाता है.
मैम अब तो मैम होस्ट है.
अनम्यूट, एक बार हमने अनम्यूट किया था, सभी स्टूडेंट्स को म्यूट किया था, तो मे बी उसके साथ थोड़ी सेटिंग्स चेंज हुई.
नहीं, ये एक्चुअली शुरू से वो बॉक्स चेक नहीं हो रहा है, कुछ सेटिंग में तो गड़बड़ नहीं है. चलिए कोई बात नहीं, मैं ऐसे ही कर देती हूँ एक बार दोबारा से. वेट, Let me just do it once more. Yeah, so please see here. And now see carefully. You can see this image, you can see the shadow, you can see the fingers, you can see the blue shirt, you can see the watch. Could you see now when I pointed out? Hello?
Yes,
Yes,
ma'am.
ma'am.
Yes. So that is what I'm saying. That invisibly we all were constrained to see somehow only the cutting of guava and falling of the guava. But there is so much of detail. There is so much of detail that when we show this to school children, there is at least 40 minutes तक वो हमें ये observations बताते रहते हैं कि ये भी दिख रहा है, एक छोटा सा पीस फ्लाई ऑफ करके गया है, एक नाइफ जो है वो रस्टेड है कहीं से, उसका हैंडल ब्राउन है, गुआवा का कलर ग्रीन है, hands are of a male person, but that is a conclusion again. That's an inference, that's not observation. So there are two things that I want to point out, that whenever we see something, the observation has to be also of the colors, the shades, the intensity, the shadow, the image, and so many more details, not just what is right in the front. Because the devil is in the detail, right? Or the God is in the detail. So it's the detail which is very important, and it's the observation of facts which will never go wrong. It's sometimes our inferences that we make that might go wrong. So first job of someone who wants to design solutions for sustainable future is to observe things as they are and not constrained by our biases, our mindsets or our limitations. वो आपने कहानी सुनी होगी ना कि एक हाथी को बचपन से एक पेड़ से बांध दिया गया, और जब वो बड़ा हुआ तो उसकी चेन खोलने पर भी हाथी वहीं खड़ा रहता था क्योंकि उसको माइंड में उसके चेन्स थी. तो इट इज दीज चेन्स दैट वी हैव टू ओपन अप, राइट? Now let me go one step further, and I want you all to do this experiment right now. Please put your fingers on your lap, on your two knees like this, wherever you may be sitting, even on a chair, and just close your eyes and please look at your breath. Just calm down, concentrate on your breath after you have put your palms and your fingers like this on your knees. Just calm down and observe your breath. Take breath, deep breath 5 times, 5-6 times. Observe the pattern of your breathing. And now turn your palms upside down like this on your knees. Turn your palms upside down on your knees and again breathe deeply. And again turn your palms upside down and breathe and notice the difference and tell me what is the difference. Once with palms up and then once with palms down. Breathe deeply and notice till you find the difference. So do you find any difference? Can you notice any difference? Anyone? Even the professors are invited to feel this and tell me. Or do it once more, deeply, close your eyes, forget everything else, just look at your breath. the way it goes in your lungs, especially with the palm turned upward and then downward. Do it 5-10 times with palm upwards. And then turn downwards. And now tell me the difference.
Ma'am, upward palms, with upward palms, it's more comfortable.
Okay,
And the direction
comfortable
is
in what sense?
that you can inhale properly and exhale for properly.
Maybe you mean more deeply.
Yeah, more deeply, right.
In fact, if you, now that I've told you, you might be able to realize it better कि ऊपर की तरफ palm करके आपका breath बहुत deep तक जाता है और जब आप उल्टा करते हैं तो breath उतना deep नहीं जाता, upper lobes of lungs में ही रहता है. So you see, this is another keen observation. And India की beauty क्या थी, that we observed outside our body also very deeply, and we observed inside our body also very deeply. And then we devised health solutions which were dependent on keen observation of breath and keen observation of sound, how the Om sound or any sound affected our body organs. And just by observation of breath and sound, the observation was made so keen that you can feel organ by organ inside your body. There were very beautiful 2 techniques which are still available in India. One is Vipassana and other one is inner engineering, authentic resources. So what I'm trying to drive at is that every solution starts from keen observation. Now I want you to observe this table, last column of this table very keenly, and tell me, what do you notice about dimension of mass? This is proper physics. So now physics students, here is your chance, right? So look at the dimensions of mass and look at the dimensions of length and look at the dimensions of time and compare and tell me, is there anything remarkable that you notice about dimension of mass? Just look at how the dimension, the power of length and time is varying and how the power of mass is varying. So if you would notice carefully, you will see that the dimension of mass varies only from -1 to +1, 0 included. But then dimensions of length and time are varying to higher powers as well. 3, 4, -3, -2, -4, and so on. But mass doesn't vary any in that way. Only -1, 0, and 1. How is that? Why is that? Now, supposing you were playing in a ground and there was an alien which visited you, and he wanted to ask for an address, and you said, okay, I'll write down the address on a paper, but go get a paper. So the alien says, paper? What is a paper? So what would you reply? How would you tell him what is a paper so that he goes and gets only the paper and nothing else? Tell me, it's such a simple question that I'm asking. It's not a very technical question, right? So tell me, what would you tell the alien that what is a paper? How will you describe it? Anybody? Is it a very tough question?
Ma'am, we can let the alien know the properties of the paper.
Fine. So who is stopping you from telling? Please go ahead and tell me what property will you tell him so that he goes and gets the paper and nothing else? You are right. You are very right. You will tell the property, but which property would you like to tell? Let's try one by one all the properties.
Ma'am, as such, the alien didn't know what paper is.
Yeah.
We can give that alien example, like if that alien is wearing something. तो हम उसको ऐसे एग्जांपल दे सकते हैं कि पेपर ऐसा ही होता है, but
हाँ, कैसा होता है वो बताओ, कैसा होता है? देखो कितना सिंपल बच्चों वाला सवाल मैं पूछ रही हूँ, आप सब कॉलेज में हो, आप मुझ पे हंसोगे कि मैम ने हमसे कितना सिली सवाल पूछा है ना। तो अब जवाब तो एक जवाब दे दो, बिल्कुल जैसा सिली सा सवाल है वैसा ही सिली सा जवाब भी दे दो।
मैम अगर हम पेपर पर कुछ लिख भी देंगे तो क्या एलियन समझ पाएगा उस चीज को?
नहीं, वो बात की बात है, अभी तो आप पेपर डिस्क्राइब करना उसको कि पेपर लेकर कैसे आए, वो तो आप क्या बोलेंगे उसको कि गो एंड गेट, दिस इज हाउ द पेपर लुक्स, this is what the property of the paper is, so that you can identify from among so many things.
ma'am, a thin sheet.
Okay, thin sheet. So वो एक thin कपड़ा भी लेके आ सकता है, thin है वो भी। फिर अब फिर कैसे differentiate करेंगे? तो this is what I'm saying, that science का जो attitude है, जो हमारा mindset है ना, it starts from keen observation, not only of outside objects or our inner systems or our inner breath, but it also means reflecting very keenly on our concepts. Paper is a concept. How do we define? आप एक कोई इतनी सारी डेफिनेशंस हम साइंस में पढ़ते हैं ना, एक मान लीजिए हम एक सर्कल की डेफिनेशन पढ़ रहे हैं, तो हम बच्चे को बताते हैं सर्कल है, तो हम ये स्क्वायर बनाते हैं कि सर्कल ये नहीं है, एक ओवल बनाते हैं कि ये ओवल सर्कल नहीं है। तो when we define, that means we are defining the constraints. We are saying this is what it is and this is what it is not. So again, that is observation of our own concepts and reflecting on our concepts very, very keenly, so minutely, that the way we define it, we must enable somebody to exactly reach on that particular object and nothing else. So this is the point I wanted to make. Observe and reflect keenly. This mindset led to discovery of periodic table, because you know Mendeleev, he used to write about the properties of different elements on playing cards, and used to play cards. He loved playing cards, and ultimately by his keen observation he arrived at patterns, and you know what is the usefulness of periodic table today, right? Now can you recognize these? These are actually HeLa cells. Has anybody heard of HeLa cells? These are world famous cells which were taken from a black woman in US. She was called Henrietta Lacks. So the shortened form is HeLa cells, and these cells are never dying cells. These were cancer cells, and they have been revolutionary in research on diverse kind of diseases. They have gone to space. Even for COVID, they have been experimented upon. So when people the doctors observed them carefully, they were amazed to find that these cells multiply at such an amazing rate and they never die. So there is a world famous book called HeLa Cells. I suggest everybody read it. It's a wonderful book which raises many ethical questions. There have been scientists and doctors and medical persona who have worked and researched on these HeLa cells, patented many discoveries, and earned millions of dollars. There have been companies who have earned millions of dollars, but sadly, the family of Henrietta Lacks doesn't even have money to insure themselves against any diseases. So this raises a lot of ethical questions also. And sustainable future includes reflecting on ethics of our discoveries and our environment and our actions that we take, right? So this was another point I wanted to make. Then you might have observed in course of your physics experiments that when you take a magnet towards the coil or you take a coil towards a magnet, do you see the deflection in galvanometer? How many of you have noticed this? Just unmute yourself and tell me, have you ever done this experiment that you've taken a magnet inside a coil and you see deflection in the galvanometer? Or you bring a coil towards a magnet and you see a deflection in the galvanometer. How many of you seen this? Just unmute yourself and tell me if you've ever done this experiment. Anyone has done?
Yes, girls.
Yes, ma'am, we have done it. We have seen the deflection, but we didn't saw the waves.
Right. So you have seen the deflection. तो अब एक वो कहावत है ना कि चाकू खरबूजे पे गिरे या खरबूजा चाकू पे गिरे, कटना तो खरबूजे को ही है. तो अब आप सोचते हो कि अगर मैं मैग्नेट को कॉइल के अंदर ले जाती हूँ और कॉइल को मैग्नेट के अंदर पास लाती हूँ, is the result same or not? The deflection in the galvanometer is same in both the cases, right? But this again raises the question that how could it be so? And do you know this question was the starting point, electrodynamics of moving bodies, which led Einstein to propose the theory of relativity. Because he said when you move the magnet, you're moving the magnetic field, and that is creating an electric field. And when in that electric field you are keeping the conductor, that is your coil, then there is an induced current there, right? But when you keep the magnet stationary and you're bringing the coil, there is no movement of magnetic field. There is no movement of magnetic field. And so there could not be any creation of electric field. Yet you see the same induced current in the coil. So how can that be? Right? So it is the keen observation and reflection that brings us to the next attitude, and that is asking questions. If you have keen observation and if you have the capability of asking question, you are right on the track towards a sustainable future. So what do we ask? This is an amoeba. You ask me any question that comes to your mind about this amoeba, right? Now, don't tell me you're a physics student and you would not ask question on amoeba, because when you go out in life, the life stares you from all the sides. It's chemistry, biology. It's not divided into any subject. As a human being, we are living in this world, and there is nobody standing with questions physics related or chemistry related or bio related, right? If we have to figure out any situation, we have to ask our own questions. So if there was this amoeba, which is not at all a physics object, what would you ask? What boggles your mind? What question comes in your mind? Any one question you tell me. See, this is what happens when we grow up. In the course of studying our books, we've forgotten all the questions, we've forgotten our childhood, we have forgotten how to enjoy our life and enjoy that curiosity, power of asking questions that we had in the childhood, right? Why is it that we've got lost in the books? Because if we don't ask questions, how are we going to think of new things and new aspects? Then everything is already discovered. Then we are dead. As future living beings, we cannot ask anything. Where are we going to go? Let me ask you, how is it that we never see any gigantic amoeba? Why is it that we always find examples of amoeba which are so microscopic that we never see them? Why don't we find a gigantic amoeba in nature? Or you might have seen this picture. Anybody see this picture, Honey, I Shrunk the Kids? Anyone here who has seen this hilarious picture? Honey, I Shrunk the Kids. You can see these kids running from the nose of this dog to the nose of this man with the specs. These are small kids who have been shrunk by mistake by the father. So do you think that if you shrunk the kids, or we shrunk ourselves to such a microscopic scale, we will survive? So why we can't find a gigantic amoeba in nature, and why we can't find a microscopic elephant in nature? Ask these questions. Then we will look for the for the reasons, because being scientific human beings, we understand that this universe is not random. Everything is related, every happening is logically related. So there is a cause and there is an effect. And only when we think about these causes and the effects and we ask ourselves these questions, why, how, then that is the time when we find those interlinks between the cause and effect. And that's how we discover the secrets of nature. You know, you've heard of Galileo. How many of you have heard of Galileo? You have? Okay, tell me, where did you hear about Galileo? What did he do so that you remember his name? Yeah? Anybody here? In what context do you remember Galileo's name? It's okay, whatever you remember. Where did you hear Galileo's name first? Okay, let me tell you. Galileo was the one who discovered that simple pendulum has oscillations of fixed time period, whatever be the amplitude. And before that, you know, we had the times of Aristotle, where Aristotle said that fiddling with nature is taboo. And just by observing nature keenly, we can learn many things, right? But Galileo said no. By observing keenly, we can see that when we change one quantity, there is an effect on another quantity. But if we want to learn the secrets of nature, we have to fiddle with nature. And by fiddling with nature means experimenting. And by experimenting, even though everybody knew that when you change the length of the pendulum, the time period changes. But what did he discover? He discovered the secret of nature, that T is proportional to under root of L and not L square or L. So these mathematical secrets of nature, that how one quantity is related to another. You know, when we ask questions, just asking questions is not sufficient to discover these secrets. Then to discover these kind of secrets, that T is proportional to under root of L, what should we do? What kind of mindset should we have so that we can understand these secrets of nature and then manipulate them to our advantage? What is that we should be doing? How do we proceed from knowing that changing the length affects the time period to a stage where we can discover time period is proportional to half power of length? How do we proceed from this stage to this stage? By exploring, experimenting, isn't it? Just knowing that time period is changed by changing the length is not enough. If we experiment and explore and investigate, then we arrive at the secrets of nature, which are in form of mathematical relationships, which are a plenty in our physics course, where our books are filled with those secrets of nature and filled with those equations, right? So what should we do apart from asking? You know, look at any situation. Supposing we want to see the magnification of any object when we put it in a liquid, okay? Then can we, if we want to investigate anything, we should ask ourselves, what are the parameters involved here, and how can I change the situation here? For example, let me show you here. I have something here in front of me. Can you please pin my screen and see here, or let me stop share and then you see myself. Can you see my screen here? Just a minute, wait, let me put it like this. Do you see these two objects? Okay. Now let me put this in this box. What do you see here? I have one cylindrical object. When I put it here, what change do you observe? What change do you observe?
It's magnified.
It's magnified. Okay. Now this is just one situation. And in this situation, what all can you change? Just tell me what all can you change, or let me show you something more here. I have a pencil here, right? And when I take the pencil to the side, what do you see here? What do you see about the pencil? Is it one pencil or it has been cut into two halves?
Ma'am, it has been cut into 2 halves.
It has been cut into two halves. Now, supposing I want to investigate this only, that when I move the pencil to the side, it is cut into halves. Here it is one pencil, but here it gets cut into two halves. Right? Supposing I have this here, and when I move it sideways, you can see not so very well, but with the pencil, you could see very well, right? So suppose I want to investigate this phenomena, that what is responsible for cutting of the pencil into two halves. So now let me begin by asking myself, what are the parameters here, or what all are the things which I can change in this situation? So can you suggest any parameter, any physical quantity that can be changed in this situation? Anything that comes to mind. One change I have made here. What have I changed? Tell me. Between this and this, what is it that I have changed?
Shape of the container.
And the shape of the container.
I have changed the shape of the container, though the side of this cube and the diameter of this are absolutely equal. You can see that these two are equal. The box is hidden, the cubical box is hidden behind it. So the diameter of this and the size of this is absolutely the same. Now, by changing the shape, now let me study this effect. You see here? You see this? It is getting cut, or let me show by the pencil. The pencil here is getting cut, right? But when I put here at the same location, is this getting cut?
No, ma'am.
Is this magnified? Let us see this. Is it magnified also as much as it is here?
No, ma'am.
No,
So,
ma'am.
so when I changed one parameter, I got certain information. What conclusion can I draw from here? See, this is one, and then this is one other. Now, when I change the shape, there is a change in the observation. What do you conclude from this observation?
One surface is a plane surface while other is a curved surface.
Right. So that is about the surface. That conclusion is about the surface. But what conclusion do you see about the what is visible in the water?
In one container, it is magnified, and in another, it is not much
Not
magnification.
magnified. Wonderful. Wonderful. So you started from the observation of the shape and you ended up on the observation of magnification. How will you connect the two observations? What is the interlink between them? By changing the surface, what is the effect? What is the change in the other observation?
Magnification changes when we change the.
So what do you think is responsible for magnification? Is it the shape, or is it the size, or is it the liquid?
Ma'am, all the three.
But
like
don't you, but how, see, this is same, the liquid is same, yet the change in size of the image is there in this, but in this it is not there.
It's like a plane mirror or a curved mirror.
Mirror. Is it mirror?
It's like a glass, a transparent, it's a glass.
So
Reflection
whatever is the
phenomena is there.
phenomena, it is not reflection, certainly.
It's a
It is
reflection.
refraction. Number two, the refraction is responsible, understood, but then it is this shape which magnifies and this shape which does not magnify. So something to do with the curvature, right? And this is the third point that I wanted to make, that whenever we talk of a sustainable future or whenever we are talking about solving our problems, what is the meaning of sustainable future? Is observing problems around us and trying to solve problems. When we try to solve problems, we have to identify what are the parameters in the problem, and by changing one of them, we try to see the effect. Again, if there is no effect, we try to change another one. And that is how we try to understand the relationships between different variables which are involved in a situation. And then by investigating scientifically, doing experimentation, we arrive at the definite relations which can be expressed in form of mathematics. And that will help us to predict what will happen in new situation and find new solutions. So this is the third point I was trying to make, that we have to think of variables and do many iterations, that by changing this, this is what will happen. By changing this, this is what will happen. And that comes from experimentation, and that will enable us to model mathematically. Okay. Dr. Neetu, do I have 5-10 more minutes? 5 minutes?
Sure, ma'am. It's
Okay.
a really interesting one.
Okay.
Okay.
So this was about iteration. Now last, if you have glasses with you. So now I'm coming to the last stage. We have done observation. We have done asking questions. We have done exploring and iterating to find alternatives, and then how finally we arrive at the solution of a problem. This I want to show you with a very, very simple task. I think many of you might be having glasses with you. Just put it towards a light source and see whether window or anything. Can you see two different images? Just take out your glasses probably and put it towards a light source. Maybe a window that you have in the room, or a tube light. When I put it, I can see images like this. Is my screen visible to you?
Yes, ma'am.
Yeah. So if you put your specs towards the light source, say a window or a tube light, do you see two images? One big, one small of the light source?
Yes, ma'am.
Okay. So now I want you to tell me, how do they differ from each other in size, position, and brightness?
The bigger one is more bright than the other one.
Okay, one image is more bright than the other. Wonderful. What about the size? Are the sizes equal for you?
No, ma'am.
No, ma'am, and the length is also different.
Different. And are they located at the same position or at a different position?
I'm at different positions.
How do you know that they are at different positions? How do you know? I mean, just by looking, how do you know, or did you do something by which you realize that they are at different positions? You're right in your observation. There are different positions, but I want you to look at your thought process and identify, how did you learn that they are at different positions?
Ma'am, there is a space between them.
Space between them, or you turned the lens, your spectacles little bit and saw that they were shifting differently. That's how you realized.
Yes, ma'am.
Right? So you looked at the parallax. Actually, you were just shifting them and seeing that they shift differently. So you realize that they are at different depths, right? And then how do they differ as compared to the source? The light source, maybe the window, or from where the sunlight is coming, or the tube light. if you compare the color and size with the respect to tube light, how is it different? What is the color of the tube light or your light source? Yeah? कैसा कलर है ट्यूब लाइट का? या जो लाइट आ रही है विंडो में से वो कैसी है? व्हाइट है, ब्लू है, ग्रीन है, रेड है? व्हाइट है, ठीक है। और जो इमेज आपको दिख रही है अपने स्पेक्टिकल्स में वो कैसे कलर की है?
ग्रीन मैम।
ग्रीन है। और किसी की भी ग्रीन है या सबकी व्हाइट है या पिंक है या कैसी है?
White and brown.
अच्छा,
It's green.
अच्छा, और साइज कैसा है? अब जरूरी नहीं है कि सबकी ग्रीन हो, किसी की व्हाइट भी हो सकती है, इसलिए डोंट गिव द सेम आंसर विच नीतू मैम इज गिविंग या मनमोहन सर इज गिविंग. सो यू सी योर ओन इमेज, राइट? अब उसका साइज कैसा है कंपेयर टू द ट्यूब लाइट और द विंडो फ्रॉम वेयर लाइट इज कमिंग? जितनी बड़ी विंडो है उतना ही बड़ा आपकी मिरर में इमेज है या छोटी है?
Ma'am, it's small.
Small,
Very
right?
small.
So this is you are observing. Okay. Now my question is, I am asking this question, which image is formed? अच्छा, पहले तो ये बताओ कि ये इमेज रिफ्लेक्शन से बन रही है या रिफ्रैक्शन से बन रही है? आप क्या सोचते हो? व्हाट इज योर इन्फ्रेंस फ्रॉम द ऑब्जर्वेशन? आपने लाइट की तरफ, विंडो की तरफ ही रखा, हाँ? तो रिफ्रैक्शन से बन रही है, रिफ्लेक्शन से बन रही है, कौन से प्रोसेस से बन रही है ये इमेज?
मैम रिफ्रैक्शन।
रिफ्रैक्शन से बन रही है। तो रिफ्रैक्शन तो आप किधर से देखोगे? अगर इधर से लाइट आ रही है सामने से और इधर से देखेंगे तो आपकी आंख में रिफ्रैक्टेड लाइट आएगी, या यहां से देखोगे तो रिफ्रैक्टेड आएगी? इधर से लाइट आ रही है और आपकी आंख इधर ही है, तो अब इधर आपके पास कौन सी लाइट आ रही है? रिफ्लेक्टेड या रिफ्रैक्टेड?
रिफ्लेक्टेड।
रिफ्लेक्टेड। तो आप किधर से देख रहे हो? जिधर सोर्स है उधर से ही देख रहे हो ना आप तो इमेज को। तो फिर कौन सा प्रोसेस बना रहा है ये इमेज?
Reflection.
रिफ्लेक्शन। ओके, नाउ टेल मी, अब दो इमेज क्यों बन रही है? रिफ्लेक्शन तो फिर रिफ्लेक्शन से तो एक ही बननी चाहिए थी, दो क्यों बन रही है? Yes, somebody is saying something.
Yes, Haraman. Unmute yourself.
यस मैम। मैम उसमें 2 लेंस लगे हैं हमारे जो स्पेक्स में है, इसलिए 2 इमेजेस।
तो 2 लेंस तो ये तो नहीं, एक ही में दिख रही है ना 2 इमेज आपको? 2 इमेज तो एक ही में दिख रही है। आप मेरे स्क्रीन पे देखो, ये एक बड़ी इमेज और एक छोटी इमेज एक ही लेंस में दिख रही है, दूसरा वाला तो हमने देखा ही नहीं अभी। एक में ही दिख रही है ना 2 इमेज तो, या नहीं दिख रही है? सबको दिख रही होंगी 2 इमेज, तो एक में 2 क्यों दिख रही है? देखो, रिफ्लेक्शन 2 जगह से हो रहा है, एक ऊपर की सरफेस है और इसकी कुछ थिकनेस भी है ना, तो अंदर भी लाइट जा रही है रिफ्रैक्शन होकर, और जो नीचे वाली सरफेस है वहां से रिफ्लेक्ट होके वापस ऊपर से निकल के हमारी आंख में आए, तो 2 सरफेसेस से रिफ्लेक्शन हो रहा है। तो एक इमेज ऊपर वाली सरफेस में है और एक नीचे वाली सरफेस में है, दोनों इमेज इधर दिख रही है रिफ्लेक्शन से। अब हम कैसे पता लगाएं कि कौन सी ऊपर वाली सरफेस पे और कौन सी नीचे वाली सरफेस पे? इसका कोई तरीका सोच सकते हो आप? क्या
Yes,
हम
कंसेप्ट लगाओ अपना थिन फिल्म्स का।
कुछ
जब आप
नहीं,
कैसे पढ़ते हो?
हमें वो प्रोसेस लगाना है कि हम क्या वेरी कर सकते हैं। यहाँ पर हमने पहले ऑब्जर्व किया, now we are asking the question. Third step is iteration and thinking of what variable we can change so that we can find out that where is this image made. ये बुक्स में नहीं है, ये चीज यहीं पे एक्सपेरिमेंटल ही है बस, बुक्स नहीं आपको बता पाएंगी ये वाली चीज। देखो मैंने अपनी फिंगर जो है पानी में वेट कर दिया, और इवन आई कैन वेट इट यूजिंग माय सलाइवा। नाउ इफ आई touch my specs from inside, you will see one of the images gets affected. Try and see and tell me which image is getting affected. नीचे वाली सरफेस को टच करने से कौन सी इमेज पर अफेक्ट हो रहा है? मैं विभूति के लिए और डॉक्टर चोपड़ा के लिए बोल सकती हूँ कि जब आप नीचे वाली सरफेस को टच कर रहे हो तो आपकी बड़ी वाली इमेज अफेक्ट हो रही होगी, वो शायद पिंकिश हो जा रही होगी जहां से आपने टच किया है। आप टच करके देख सकते हैं उसको। जस्ट वेट योर फिंगर विद सलाइवा एंड पुट इट हियर and then see the image. So that is how you can change variable. How did I change? I just changed, I touched one of the surfaces. I could have done that, no? I touched one of the surfaces and that told me ki which image is getting affected. That means that image is made by reflection from the lower surface. So my problem is solved. But I now can ask another question. Can we find the nature of spectacles just by looking at the images? अब ये जो इमेज मुझे यहाँ दिख रही है, अगर मुझे ये पता लग जाए कि ये बड़ी वाली इमेज जो है नीचे बन रही है या दूर है, या ये नीचे वाली उसमें बन रही, मैं कह सकती हूँ कि हर व्यक्ति का चश्मा वो वाला पढ़ने वाला चश्मा है, दूर का चश्मा नहीं है। अब ये फोर्थ स्टेप है कि मैंने इस प्रॉब्लम को सॉल्व कैसे किया। ये मैंने ऐसे सॉल्व किया कि मैंने ये चेंज करके, ये जब हाथ लगाया गीले पानी का तो ये इमेज मेरी पिंक हो गई। तो ये मुझे समझ में आया कि बड़ी वाली इमेज इज मेड इन द लोअर सरफेस। नाउ व्हाट, हाउ डज दैट हेल्प? दैट हेल्प्स बिकॉज इट टेल्स मी व्हाट, दैट माय मैग्निफिकेशन माइनस v by u। अब u तो सेम है ना दोनों सरफेस के लिए, ऊपर और नीचे दूर, the source is at the same distance. So if image is bigger, v must be bigger. That means the bigger image is formed farther off. Now if that is formed farther off, then u is same in this formula, v is greater for bigger image, so r is greater for the bigger image. That means जिस सरफेस पे ये बड़ी इमेज बनी है उसका रेडियस ऑफ कर्वेचर ज्यादा है। Is that clear? Now you have to turn the pages of your book. कि अब इस फॉर्मूला से मिरर फॉर्मूला जब मैंने लगाया, क्योंकि मैं कर्व सरफेस पे रिफ्लेक्शन की बात कर रही हूँ, so if u is same but v is greater for a bigger image, then for that image the surface must be having the greater radius of curvature. If that is having greater radius of curvature, अब आप लेंस फॉर्मूला लगा लो। आपको लेंस फॉर्मूला तो पता ही है, P equal to what? Mu minus 1 over mu minus 1 into 1 by r1 minus 1 by r2. तो अब अगर लोअर सरफेस का रेडियस ग्रेटर है तो कौन सा r ग्रेटर हुआ? ये लोअर सरफेस का r ग्रेटर हो गया ना, हमने अभी निकाला, और ऊपर की सरफेस का रेडियस जो है वो रेडियस कम है। तो क्या इससे पता चला कि ये हमारा कैसा लेंस है? कॉन्वेक्स लेंस है। और कॉन्वेक्स लेंस का मतलब क्या डिफेक्ट ठीक हो रहा है? वी आर हाइपरमेट्रोपिक, पास का चश्मा है। और अगर हमारा अपर सरफेस का रेडियस ऑफ कर्वेचर ज्यादा होगा इस तरह का, तो फिर ये कौन सा लेंस हो गया?
कॉन्केव।
हाँ, कॉन्केव लेंस हो गया। दैट मीन्स ये चश्मा दूर का। तो बिना मैंने आपका चश्मा छुए, आपकी ऑब्जर्वेशन से मैं बता सकती हूँ, इस इमेज की ऑब्जर्वेशन से, कि चश्मा पास का है दूर का है, तो प्रॉब्लम सॉल्व हो गई ना। सो दिस इज एग्जैक्टली द माइंडसेट that takes us towards a sustainable future where we are able to observe the the happenings around us keenly. We ask questions. We think of what variables we can change, and we iterate that by changing this, this is what will happen. By changing this, this can happen. We try out a lot of iterations and explore and investigate through experimentation, and finally we solve our problem. Now, this I have taken example from physics, and these are very simple examples. Probably you might think that they're very silly, but then the same lessons apply for solving any problem. You see, always we will be coming across situations which are new in our life. How do we make sense of those situations? There's no teacher standing there with us, no parent standing with us. We don't have books there ki jiska padna paltenge. Okay, maybe you will have watches which will be like computers, and you will connect to internet. But then internet may not have solution to all the problems. Local problems, especially local problems, internet may not have solution. Then what are you going to do? So then it is only our mindset that will come to our rescue. Mindset of observing very minutely and do not mix up with inferences. Then reflect, ask questions, see what parameters you can change, what is affecting what, find the correlation, and then look for causation in terms of mathematical relationship, which will enable you to predict that how you can change your future. By changing this much of change you can bring in this quantity, right? And that might solve a problem. That might take you towards a happier future. You might solve a health problem. You might solve an environmental problem. You might solve a relationship problem even, right? So I think this is the mindset that everyone requires, and more so a science student. So thank you so much. I hope that I have done justice with the topic that you had ordered, Dr. Chopra.
Thank you so much, ma'am.
That's
Really,
all.
it was a wonderful interaction.
Thank you
And,
so much, children. I hope that you will continue to not hesitate in answering, because see, every thought that you give us is a valid thought. Whether it is correct or incorrect, that is left to be checked. And that checking we do by experimentation or relating to our theoretical concepts. But never be afraid of giving your thought. Every thought that comes to our mind is valid, and it deserves respect. It deserves due consideration. The only thing that remains to be seen is its validation through experimentation or theories. So I hope that in any future interaction, you will not hesitate. You will not worry about going wrong. Because unless we take that risk of going wrong, we'll never be able to solve our problems. We will only look to other people for solving our problems. And when we look to other people, we live a life of being a follower. We live a life of compulsion, that whatever else decides, whatever somebody else decides for us, we live that life, right? And especially for us ladies, there is a no, I don't want to say that word. We don't want to be compelled to live through a situation. We want to chart out our own course, right? So don't think that being ladies, we are not capable of doing that. In fact, we solve more problems in our daily lives at home, outside, though we are not aware of that thought process in our mind. So it's extremely important to be aware of that thought process through which we are going. And that is nothing but in very sophisticated, big terms we call as critical thinking. But that critical thinking is not foreign to us. Okay? So believe in yourself. Don't worry about what anybody says. Just come out with your thoughts. Okay? Thank you so much.
Thank you so much, ma'am, for enlightening us with your knowledgeable and kind words. It has been a wonderful session for all of us. Now, I would like to call Madam Neetu Chopra for the vote of thanks.
Thank you, Vibhuti. Yes, ma'am. It's a really not a formal vote of thanks. It's a big thanks to you, ma'am, for having your gracious presence and having so much interactive session with our students.
Thank you.
I hope students, ma'am, really you have made our students to observe critically and to do critical thinking beyond the space for the sustainable growth. I hope such interaction will help the students to explore the day-to-day activities around yourself in a scientific way. Once again, thanks a lot to you, ma'am. And thanks to all the participants for your patience hearing and valuable participation. Thank you, ma'am. Hope to have a such wonderful interaction in the future too, so that we can have some more experiments to think critically and to observe deeply.
Sure, my pleasure. Thank you so much.
Thank you so much, ma'am.
Thank you, ma'am. Thanks.